Hello everyone, welcome to Vardhaman. Myself Dr. Ramesh. In today's session we are going to discuss about nanomaterials. In that classification, synthesis and applications of nanomaterials. In general, materials are three types. One is macro, other one is micro. In between macro and micro, nanomaterials are there. In other words, the materials whose size in between 1 to 100 nanometers are called as nanomaterials. The materials whose size in between 1 to 100 nanometers are called as nanomaterials. This is the size scale. On this scale, 1 to 10 to the power of 2 is nanoscale. Here some molecules are there. Some molecules or materials are there. In that, first one is DNA, antibodies, oligonucleotides, virus, protein, glucose. These are all biomolecules which comes under nanomaterials or which size present on nanoscale. And also these materials, fullerene, dendrimer, quantum dot, gold nanoparticles, metal oxide, liposomes, polymers. These are also comes under nanomaterials or nanostructures. Then remaining, the bacteria whose size is 10 to the power of 3. And cancer cell, pencil tip, tennis ball. These are all having more than nano size. These are all comes under macromolecules. Here, water is there, whose size is 10 to the power of minus 1. This is comes under micromolecules. Once again, I'll repeat. Molecules or materials are three types: macro, micro and nanomaterials. Here nanomaterials present in between macro and micro molecules. Classification of nanomaterials based on dimensionality. In that, first one is zero dimension nanomaterials. Nanospheres, nanoclusters comes under zero dimensional nanomaterials. And quantum dots, fullerenes, gold nanoparticles, these are also comes under zero dimensional nanoparticles because of these are all looking like spheres. Next, one dimensional nanomaterials, nanotubes, nanowires, rods, metal nanorods, ceramic crystals. Next, carbon nanotubes, metallic nanotubes, gold nanowires, polymeric nanofibers, self-assembled structures. These are comes under one-dimensional nanomaterials. Next, two-dimensional nanomaterials. Two-dimensional nanomaterials, these are looking like films. Thin films, plates, layered structures comes under two-dimensional nanomaterials. Examples, carbon-coated nanoplates, graphene sheets, and other layered nanomaterials. Three-dimensional nanomaterials. These are bulk nanomaterials or polycrystals. Examples, liposomes, polycrystallines, dendrimers. These are all comes under three-dimensional nanomaterials. Next, classification of nanomaterials based on its composition. Carbon-based nanomaterials. The materials whose are made by carbon or carbon containing compounds, those are carbon based nanomaterials. Examples are fullerene, graphene, nanotubes. These are all made up of carbon. Metal based nanomaterials. In these materials, metals are major constants. Examples, metal crystals, metal oxide, resistors, metal decorated multi-walled nanotubes. These are all comes under what? Metal based nanomaterials. Next one, nanocomposite. Composite means material which is made by two different metals. That is what composite. If the composite is present on nanoscale, that is what nanocomposite. Here, cobalt chromium nanocomposite means this material is made up of cobalt and chromium. One more is palladium titanate composite. In this metal oxide, palladium is there, titanium is there. Because of this is a composite. Last one is dendrimers. Dendrimers. Regular dendrimers. Dendrigraphs. These are what? Dendrimers. Classification techniques for synthesis of nanomaterials. Here two types of techniques are there. One is top-down approach. Second one is bottom-up approach. These two techniques are used to make or synthesize nanomaterials. In that first one is top-down approach. In top-down approach, bulk material converted into nanomaterials or particles. For this we can say one example. If one building is there, that building is made up of bricks. Building is a bulk material. If we deform the building, we will get what? Bricks. Here, bricks are nanomaterials. Building is a bulk material. If we deform or destroy the building, we will get what? Bricks. Here, bricks are nanomaterials. In the top-down approach, bulk materials converted into nanomaterials or nanoparticles. Here, high energy wet ball milling, gas phase condensation, aerosol spray method. These three methods are comes under top-down method. Top-down method, right? Next, bottom approach method. This is reverse to top-down method. In this method, atom or molecules. In this method, atom or molecule. Atom combine with atom or molecule combine with molecule. Or atoms or molecules combine with each other, converted into a nanomaterial or nanoparticles. Here, atoms or molecules combine with each other, converted into nanomaterials. Here, small particles converted into nanomaterials. This is what bottom-up approach. Bottom-up approach. Here, for bottom-up approach, examples are sol-gel synthesis, precipitation method. Next, salvo-thermal synthesis, thermolysis. These four techniques or methods which are used to synthesis of nanoparticles comes under bottom-up approach. Next one is, in that first one is sol-gel method. Sol-gel method is a good technique which is used to synthesize nanoparticles. In this method, or this name indicates sol converted into gel. Gel upon heating converted into a powder or nanomaterial. In this method, or this name indicates sol converted into gel. Gel later converted into a desired nanomaterial. Right? Here, in this method, reactants or reaction precursors are metal alkoxides. These metal alkoxides upon hydration converted into metal OH, alcohol. This reaction is what? Hydrolysis reaction. In this reaction, hydrolysis takes place. That is what? Hydrolysis, nothing but formation of sol. In the first step, metal alkoxides upon hydration or hydrolysis converted into metal OH and alcohol produced. This is what sol formation. In our sol, metal OH and ROHs are there. Right? Next, gel formation. In gel formation, condensation takes place. That is what polycondensation takes place. Condensation means a removal of water or dehydration. In this step, water condensation. First one is water condensation. Hydrolyzed species condense, releasing water. Releasing water, nothing but dehydration. Metal OH linkages which are present in the gel combine with each other, converted into metal oxy metal linkages plus water. Next, second step comes under gel formation. That is what? Alcohol condensation. Hydrolyzed species. That is what? Metal OH. Metal OH is hydrolyzed species. And unhydrolyzed species which is metal alkoxide. Metal alkoxide converted into metal oxy metal linkase and alcohol. These two steps are involved to form a gel. right? In gel major components are what? Metal oxy metal linkages. Next, aging of gel, during which polycondensation reaction occurs. Next step in sol gel synthesis, drying. In sol gel synthesis, first step is salt formation, second step is gel formation, third one is drying. Drying. If the gel is dried by evaporation, then the capillary forces will result in shrinkage. The gel network will collapse and a zero gel is formed. If the drying takes place by evaporation of solvent, then we will get what? Zero gel. If the drying takes place under supercritical conditions, we will get aerogel. We will get aerogel. Here, the difference in between zero gel and aerogel is, in zero gel, there is no pores in the gel clusters. Gel collapsion takes place in the case of zero gel. In the case of aerogel, there is a pores in gel structure, right? Density is low in the case of aerogel comparing with zero gel. Finally, final step in sol gel synthesis is calcination. Calcination is a process in which we need to heat the compounds heated at 800 degrees centigrade to get our desired product. Calcination is a process. This is a heating process in which whatever the zero gel or aerogel formed in this method heated to 800 degrees centigrade to get our desired product, right? In this calcination process results in densification and decomposition of the gel takes place. Next, advantages of sol gel method. In this method, mono-sized nanoparticles are produced. It is useful for the synthesis of glass ceramics, ceramic materials at lower temperatures. These two are advantages of the sol gel method. Disadvantages: controlling the growth of the particles. Controlling the growth of the particle size is very difficult in this method. Avoiding the agglomerating of new formed materials, that is also very difficult in this method. These are the two disadvantages of sol gel method. Once again, I will repeat, sol gel method involves salt formation, gel formation. In salt formation, major components in sol is what? Metal OH and alcohol. Next, gel formation. In the gel major components are what? Major components are metal oxy metal linkase. Later, this gel evaporation or drying, right? Drying takes place. That is what? Zero gel, aerogel. Zero gel, there is no pores in zero gel. In aerogel, there are pores, right? Finally, after drying, we need to calcinate the compounds which are obtained at 800 degrees centigrade, right? Finally, we will get our desired product. We need to do the XRD to get the exact structure of the nanomaterials. After calcination process, we need to go for XRD to decide the structure of our desired product, whether it is formed or not, right? These two are advantages, these two are disadvantages, right? This is about sol gel method. This is the graphical representation of sol gel method. This is the graphical representation of sol gel method. This is what precursors in solvent, salt formation. In salt, colloidal structures are there. This salt later converted into what? Gel. The gel drying in three ways: supercritical drying, thermal drying, freeze drying, right? That is aerogel, zero gel and cryogel. These gels, finally calcination takes place. Calcination, we will get our final product. Whether the product is formed or not, we can decide by recording XRD, right? This is about sol gel process. Thank you.